So why don't we talk about, like, we kind of talked about the most extreme edge of complexity in terms of controls, and there's a reason why it's complex. We'll talk about this in a minute, but let's go back a little bit and talk about, a configurable controller versus a programmable controller. We talked a little bit about the programmable a minute ago. We kind of got a little ahead of ourselves because I got excited about it, but let's step back and talk about configurable versus programmable. So who wants to tell us about configurable controls?
So I'll start here because this is kind of going backwards in the regard of what is the intent and tolerance of the project, because that's really where controls, that's the, basically we're talking controls 101. That's the first question everybody should ask. Unfortunately, right now in the industry, what's the first question we have? Well, what's your sequence of operation? Yeah. Well, it doesn't really matter. What's your intent of the space, and what are my tolerances? Can I do something that's 60 to 80 degrees and I don't care about RH?
Absolutely.
AKA a dog kennel. Or do I have to do something that's a pharmaceutical mixing, compounding drugs, and if anything goes haywire, we have to do that? So the concept is really step back and look at it. So this is actually where commissioning can actually get us in trouble at times, because it says, well, the plans say it has to do this. Well, what's the intent of the plans? Not, hey, by the way, it has to do this at this point, right? Okay, if we got into that detail, most engineering, most processes, most projects, we're never looking at a piece of equipment. We're looking at a system. And what is that system? It's the air coming in, the air going out, the people walking in, the people walking out, the skin, everything there. And so once you understand the intent, we know we've got to control to a certain way. We now know sensors that we need. Then we say, all right, what's the tolerance? How critical is the tolerance? Is plus or minus 5 degrees okay? It's plus or minus 5% RH. So the tighter, the more precise the intent, and the tighter the tolerance, the more difficult the controls. Now, every manufacturer comes up with a controller. They have their own controller, and it's what we call configurable. It has their canned program. They've written this program in such a way that it handles as many of the projects they can think of, all hitting it at once. But it's configurable to do that and to control it. It's the sequence is by that manufacturer. They look at the designed intent of what's going on. You have set point adjustments, and you have a variation of sensors, whether they're communicating of sensors and set points. That's really just configurable. And then once you get in, and so you don't step away from that programmable yet, it's still semi-programmable, but the sequence is maybe not as adjustable as you would like. Now, the other thing about that last picture that we actually did have, which is it's a fully programmable controller, but it's only programmable to the person with the right tools and the right passwords.
Right.
So, Tony, that is not a programmable controller for you. It's a configurable controller.
Right. I understand.
You don't have the tools.
Thank goodness.
To do it.
Yeah, I don't have the tools, nor do I want them.
And so, but that's where you get the self-proclaimed guys like us that really live, breathe, love the psychrometrics. We want to say, we all like that programmable. We like to get to that side of where it can really do pretty much anything.
Right.
And so, but at the same time, we always talk about the more custom you get, the more cost you also get. Yeah. And so if a configurable manufacturer supplied controller is the right choice, it's absolutely one of the best directions you can ever go, because it is pretty well vetted. Now, are they going to have firmware updates? Are they going to have always? I've never seen a car without a recall yet. So therefore, we've got that we have to deal with. But really, that's the fundamental difference of go back to the basics of understanding controls is, how do I want to control this room? How do I want to control this space? And how tight do I have to control it?
Very good. So that would be, so just to recap, the intent is our objective in the space in terms of temperature and humidity. Is that correct?
It can be, but again, you think about it. It's like, well, we have, I mean, that's where, again, I like picking on ASHRAE because I work with ASHRAE a lot within society. I'm actually society, go to all the meetings, all that kind of stuff. But it says, you think about in our industry right now, oh my gosh, it's 65% RH. So that doesn't tell me anything, because what we have that whole chart that said it's got to be 30 to 60% RH. No, it depends on the application. It's always dependent on what you're going. And so the people who do come in and say, hey, by the way, we got a problem at 65% RH, and that's all they tell you, it means they don't understand. It's relative to temperature. And without the temperature, I did not hear anything. You didn't actually tell anything, because I had a service call one time and said, hey, we have a serious problem. It's 36% RH. It's way too high.
Yeah.
All I was told. Like 36%, great. All right. In their defense, it was supposed to be 30%, but the temperature was 48 degrees.
Right.
It's about a 23-degree dew point, if I remember.
Very low dew point, right.
And so in their defense, it was supposed to be 55. So what did I tell them? Turn on the heat. We just need to warm it up. So just having relative humidity, or being scared by relative humidity and being scared of the psychrometrics, doesn't really get us there with what the true intent is. We want to understand, what are we trying to really control? We have spaces we try and control to 75% RH. I had one that was interesting. A customer came to me and said, hey, we need 7% RH, because they were so used to talking RH, and they started telling me about the intent of their application. And after I dug into it a little bit, they did want 7% moisture content in the product, which was about 35% RH in the space. That's where the equilibrium point was. So you have to understand what true RH means and where you're going after it to truly understand the full intent and the full level of control. Because what do we want as controls programmers? Huge deadbands, plus or minus 10. What the users want, plus or minus 0.1. Well, if you want plus or minus 0.1, I'm running heat and cooling at the same time. I'm doing a Tony Mormino. I'm dehumidifying by having upstairs and downstairs in different modes.
Patent pending.
That's what you have to do if you want super high tolerances. You get into those type of things, and as you get more and more sophisticated, as those tolerances tighten, you only want to tighten them to what's absolutely required. And then if it's required, you figure out a way to make that happen.
Right. And sometimes we give them a budget. For this tolerance, you're looking at this. For this tolerance, you're looking at this. And, you give them 3 options. Usually that determines the intent tolerance pretty quick.
The description I ever had of that was talking about equipment that's explosion proof. I can make open flame explosion proof with enough numbers in front of the decimal place.
Yeah. And nothing comes free. That's for darn sure. So I love the idea of focusing on the intent and tolerance rather than the sequence, because we could get there one way, but another vendor could get there another way. But the intent is still met by doing that. So focusing on the sequence doesn't. So yeah. So Kirk, any thing to input on this slide? Configurable controllers.
I think covered it. Chris covered it pretty good.
How many of our jobs are configurable controllers? We sell a lot of like dehumidification equipment. So versus custom controllers, 90%.
I would say it's a high percentage. It's probably somewhere in the 85% range, 85 to 90. It usually, just as Chris explained, the intent, right? What do we need it to do?
Right.
And the best controller, honestly, is the controller that can fit your intent and tolerance and cost you the least amount. So if that configurable controller is the right solution, then that's what we should roll with. But when it's not,
for sure,
you sit down and you do the same thing. You figure out what the best controller is for the application.
Yeah, it goes back to just keeping it as simple as it needs to be to meet the intent and tolerance. I love it. So, okay, well, so this slide is showing another type of programmable controller. We looked at one earlier, and we talked a little bit about what's on this slide, but I felt like it was a good time to talk about it. But this is the same thing. This is a fully DDC programmable blank slate controller. So this is the next step up from a configurable controller, that we looked at before. Is that correct?
Yeah, absolutely. But just as the one you showed earlier, we bring information in, we send commands out, right? It's a blank slate when we get it. It gives us the ability to, match sequences and intent, but gives us the opportunity to write and create the logic. And while that's probably terrifying for some people, we really enjoy it. I do feel like you have to have a special aptitude just to get into the programming side and what it takes. But once you get away from configurable and you get to programmable, you get you increase your options, which again is what drives your price up, right? Is you have different interfaces, you have different ways you can communicate, and the flexibility is almost limitless, right? It just becomes, what do you want to do?
Right.
They're great controllers, obviously.
Yeah. So again, this is another panel, and just to kind of break this down, so I think what I've circled here is the actual DDC controller, the programmable brains of it.
So ironically, that the top one you circled is the actual brain.
Is it really?
Yes,
Okay.
it is, which is really cool because most of the time you don't get a brain and the display built into one, which is exactly what you're used to seeing. So,
right.
But in that scenario, that bottom panel is what's called an expansion I/O module. It gives us more points. So that top one is the brain, and which is great. Again, that's more and more advancements in technologies. Who knows what 2024 and forward are looking like? But to have a brain with a display like that is huge.
So it's built into the display. And so this on the right and then on the bottom, what I circled are both input and output boards.
Correct.
It's
Correct.
expansion board. And then, I'm sorry, there's expansion board on the left. And then this is just the terminals where you just
correct.
connect them.
Yeah, we just make it easier
Yeah.
to label, make it easier for guys to wire in the field.
That's nice. Chris, anything to add to that?
No, we're good. I mean, because even the next page still just shows another model of that. If you go to the next page, again, it's still talking about that flexible configuration and layout. Same concept. It's just another one. It's just another brain. It's another controller. It's got inputs and outputs, and one size does not fit all. That's the one thing where we want to think about it is, as you're going through this, we really want to say there. I mean, we talk about it as many controls contractors look at it this. They say, well, we got a brand that we use this brand and we do everything with it, which is fine, and it still does work. But then we look at it as one size doesn't fit all, because if you actually look at most controls contractors, they don't have one brand. They have multiple brands. And the reason being is because as you get more sophistication, it's like you said, the more sophisticated you get, the more cost you have, and we have to deal with those things in that cost.
Good point. I forgot to even mention that. So this controller we're looking at here is the high end of our programmable line, which most controls people have. And then they have a medium grade one, which we looked at before, which may be better for like hospitalities and stuff like that. This might be more of like grow rooms, surgical suites, things along those nature.
We have a question that did pop up, and this is a fun question for this intent and control. And so the question that came in, what level of detail do we as a controls group want to see from a specifying engineer, assuming they're not a controls expert or controls programmer? Well, most of the cases, not to be too flippant, is we already know that. We know they're not controls experts. We know they're intent experts, their design, their things like that. And so what we really want to see is just simply the intent, and everything else comes with it. And we're a little bit different in the fact that, let's say we have a unit, and that unit's for makeup air. That's all I need to know is I know it's a makeup air unit. And then I ask the question, all right, what am I feeding and what's the tolerance of the space? So I want to hold between, let's say, 68 and 72 degrees, and I want it to be dry. I want it to be within that 60% RH and below. At that point, that's all we need from the specifying engineer to say that's exactly what we're trying to hold. We know what we're trying to hold. We know the moisture level we're trying to hold. And we now know we're going to look at the sensors that we need to accomplish that. So if we think about it from that psychrometric perspective, what's our problem? Our problem is the moisture in the outside air if we're in the southeast. If we're out west and someplace is dry, I may only need temperature. I might not need moisture control. But then I say, all right, I'm going to start with that. That's going to tell the unit what to do. Because we know what's hitting it first is the outside air. And now we know we want to get it to that space temperature of that 68 to 72 and dry. We now know the tolerance, and we know all the pieces and all the sensors associated with accomplishing that. And then the last piece we need to know is how close can we get to that measurement of that temperature in the space, because there's makeup air units that have no space temperature. And so they just do neutral air all the time. Well, I always say I don't like neutral air machines. And the reason I say that is because where should you measure the temperature? Well, you should measure the temperature as close to the person as you're trying to make happy. If it's a hotel hallway, it's in the hallway. If it's at a university, it's probably the dean's office or the assistant to the dean. Where do we want to measure that temperature? And then that's where we want to put the final control. But if it is a high volume outside air unit or 100% outside air unit, we're going to look at that air coming in first to decide what mode we need to be in. So it goes back to a mode versus control. And we always recommend as few points as you need to control, because we can actually see what's going on with just the sensors we need to control. Informational sensors, which we see all the time, are one of those things that actually makes controls more complex, because the more sensors you have, the more you have to troubleshoot, because you don't know if it's part of your sequence of operation or not. And so again, minimize the sensors to do exactly what you need. And then if we need to vary fan speeds, things like that, we know the rest of that because we do know the intent. And from an efficiency standpoint, we drive that. We can drive all those different pieces. So again, it all just typically does come down to what's the intent of what we're trying to control and what's temperatures and humidities we're trying to hold.
Excellent. Great question, Evan Hall, by the way. And if you have other questions, please drop them in the chat.